Hi, I was in such a rush to record this. I recorded all this, but it was just my face and you didn't see my screen. So if I talk really fast or I'm not explaining things, it's because I've already explained them. We're talking about lesson 6. It's on probability. It's called probability rules. And we're going to be talking about the complement today. We've talked about the complement before. So today we talked about soccer players and it was like soccer players. And then the complement was soccer players with a little c. And what that means, it's 1 minus all the soccer players because it's the probability of this, but take it away. I mean, you've been doing this naturally in your head, but we're going to talk about it in terms of probability. So just know that the complement rule in probability, one of the rules, that may show up on your lunch, is that the complement is the probability of not A is equal to 1 minus the probability of A. Very important. Please write it down in your notes right now. This is for lesson 6. Okay, example 2, formula for conditional probability. We've been talking about conditional probability with our two-way tables. It's like, what is the probability of picking super strength if you know that the person that you picked is female or something like that. We know about these conditions now. And now we're going to add some notation to it. The notation's kind of weird. Let's talk about notation really fast. Notation, probability of something. So we'll either do A or B. And so this is probability of, and then I'll say some kind of word. And then I will say inside the argument sometimes. And what I mean by that is those parentheses. I mean that like that's the argument inside the parentheses. It's like function notation, but I use it for probability as well. Okay, let's go back to this. Shall we? Okay, where did it go? When a room is randomly selected in a downtown hotel, this is example 2. The probability that the room has a king-size bed is 62%. The probability that the room has a view of the town square is 43%. And the probability that has a king-size bed and a view of the town square is 38%. Let A be the event that the room has a king-size bed. Let's start labeling this. King-size bed, A. Okay, let B be the event that the room has a view of the town square. So what is the meaning of the probability of A given B in this context? Don't do that. Okay, let's talk about the meaning of probability of A given B. So we're going to try to find out what is the probability of getting a king-size bed, because that's A. I pointed on my screen, but okay. Probability of getting a king-size bed given. So what do we mean by given? Given is like that's where the condition is, given. In this case, I'm going to replace the word given with knowing that, so you can do the same too. So what is the probability of getting a bed knowing that the bed is in a room with a view of the town square? So now, not only are we just going to count the probability of getting a king-size bed, but we're going to find the king-size bed out of all the rooms that face the town square. We're going to use this hypothetical 1,000 table. Hypothetical 1,000 tables are awesome because the first box you fill in is 1,000. The probability of the room getting a king-size bed is 62%. So out of the king-size bed column right here, this total is going to be 62%. 62% of 1,000 is 620. Nice. If this is 620, then this must be 380. Just like, let's get that out of the way. It's the complement. 1 minus the probability. Okay. The probability that the room has a view of the town square is 43%. So this is 430 because 43% of 1,000 is 430. And the complement of this is going to be 57? 50s, 570. Okay, moving on. The probability that a king-size bed and a view of the town square, so in my Venn diagram of life where I have a king-size bed and a view of the town square, the and portion is right here, and that's 0.38. So king-size bed and a view, that's 38% or 380. Ooh. Okay, so this is 380 and this is 430. then this must be 50, 50, 1, 2, 50, 50. Which works out because if this is 380, then this is going to be 3, I'll just do it over here, 620, 380. 240. Good job for those of you who beat me. If this is 240 and this is 570, then we have, and then right here. So we have 330 left over. Okay, we filled out the table. Ooh, we're really good at those now. The conditional probability is we need to find the probability. Here's our given, or here's our desired number. We want to know how many of these are out of this total. Why this total? Because we know that the bed already has a view of the town square. So our total is out of all the beds in rooms that have a view of the town square. So this is why 430 is our total, and our desired number is 380. So that's how we know here that the conditional probability is 380 over 430. We're going to come back to that. Why do I know we're going to come back to that? Because I've done this like a million times now. Because this is actually, oh gosh, I really hope it's full name. Okay, there's also a formula. Those of you who really like formulas, here it is. It's for you. Write this down. Everyone, regardless if you like formulas or not, write this down. P of A given B. This is a conditional probability. I cannot highlight our vocabulary anymore. Actually, I can highlight it a little more, just a little bit more. Conditional probability. P of A given B is P of A and B. Okay, so both a king size bed and a town square divided by P of B, which is all of the rooms that face the town square. So let's use the formula. P of A and B, king size bed and town square. Okay, that's 380. And then divide it by P of B. P of B is the probability of B, which is the view of the town square. So the probability of getting a view of the town square is 43%, so 430. Boom, you do this and you're gonna get 0.88. How do I know this? Because I literally just did this and it didn't record twice in a row. Ta-da! Same. Now you can find conditional probability in a table, and you can find conditional probability with a formula. I like to use the formula, but I actually kind of like to use the table now that I've done it many times. I'm going to leave you to do the last question. How does the probability you calculated using the formula compare to the probability you calculated using the hypothetical 1000 table? Instead of a summary, you're going to finish this as your last question. Peace out. Bye.